Hi, my name is Hyunkyun Yu, and my student ID is 230-350-10361. My email ID is y.hyunkyun at op.iitg.ac.in. And the program that I'm in is Bachelor of Science Honors, Data Science and AI. And the course code is DA378. And course name is Internship 2, Term Project 2. And this is for trimester 8. And the title of the term project is K-means clustering of organizational value internalization using self and other assessments. More specifically, it examines how employees perceive their own internalization of organizational values and how colleagues observe those values in actual workplace behavior. Problem background. The organization studied in this project is a South Korean edtech company with approximately 1,000 employees. The company has a 7-part organizational values frame called R Beliefs. These values are intended to guide how employees think, collaborate, and behave at work. A conventional culture survey often reports a single enterprise average score or an item-level heat map. However, that can hide important patterns. For example, 2 employees may have similar average scores, but one may rate themselves higher than colleagues do, while another may be self-critical despite being highly recognized by others. Those 2 employees should not receive the same organizational development interpretation. One may need more transparent behavioral feedback, while the other may need recognition or confidence building. So the key problem was this. Can we identify meaningful employee segments by comparing self-assessment and other assessment patterns without using job grade hierarchy or organization as clustering inputs? The project had 4 main objectives. First, to construct employee-level features from self-assessment and other assessment data. Second, to select a reasonable number of clusters using the elbow method. Third, to implement K-means clustering and describe each cluster by its centroid and size. Fourth, to translate the statistical clusters into responsible HR interpretations for organizational development. An important limitation was set from the beginning. The clusters should not be treated as performance labels, personality labels, or appraisal categories. The purpose was descriptive, people analytics, not employee evaluation. Tools and technologies used. For implementation, I used Python as the main programming language. The main data processing workflow can be implemented with Pandas and NumPy for data cleaning, aggregation, and feature engineering. For clustering, I used the standard K-means workflow available in scikit-learn, including repeated initialization and a fixed random state for reproducibility. For visualization, I used matplotlib to create the elbow curve and the 3-dimensional cluster plot. I also used the local development environment such as VS Code and Jupyter-style notebooks to inspect intermediate outputs, validate the feature engineering logic, and prepare the final report. The analysis itself was unsupervised. There was no target label, so tools like accuracy or F1 score were not relevant here. Data and feature engineering. The behavioral reference period was January through March 2026. The survey was administered in April, clustering was performed in May, and report preparation began in June. The instrument contained 7 value groups and 13 items for each rating source. 12 items were 5-point Likert items, and the final yes or no item was encoded as 1 or 5 according to the established scoring rule. The April review produced 941 respondents. After 7 records were removed under predefined rules, the final analysis used 934 complete employee profiles. For each employee, I calculated 3 features. The first feature was the employee's mean self-assessment score, which I denoted as S. The second feature was the mean others assessment score received from colleagues, which I denote as O. The third feature was the sign gap, defined as G equals O minus S. A positive gap means that employees rated the employee more favorably than the employee rated themselves. A negative gap means that the employee rated themselves more favorably than colleagues did. The final clustering vector was therefore S, O, and G. K-means and model selection. The project used K-means clustering, an unsupervised learning method that partitions observations into K-groups by minimizing within cluster square distance. Because the objective was descriptive segmentation, there was no train test split. The full set of 934 complete profiles was used for clustering. To select K, I fitted candidate values from K equals 2 to K equals 8 and examined the inertia curve. Inertia decreases as K increases, but choosing too many clusters would create a complicated taxonomy without practical HR value. The elbow method looks for the point where adding another cluster gives a much smaller marginal improvement. In this project, the visible band supported a 4-cluster solution. Technically, the K-means model used K-means plus initialization, 50 starts, and a fixed random state. This helped reduce sensitivity to random initialization while keeping the workflow reproducible. Results: 4 employee profiles. The 4-cluster solution produced interpretable self-other patterns. Cluster 1 was named self-assured other critical. This group represented 170 employees, or 18% of the sample. Their self-assessment mean was 4.62, but their other assessment mean was 3.98, giving a negative gap of minus 0.65. This suggests strong self-confidence but comparatively stricter colleague observation. Cluster 1 was named mutually affirmed value embodiers. This group represented 251 employees, worth 27%. Their self and other scores were both high and almost aligned, with a self mean of 4.39, other mean of 4.37, and gap of minus 0.02. This gap may be useful for peer modeling and value storytelling as long as it is not treated as an elite category. Cluster 2 was named Mutually Critical Perfectionists. This group represented 235 employees, or 25%. Their self and other ratings were both relatively strict and aligned. The interpretation is not that this group is weak, but that they may apply demanding standards to both themselves and others. Cluster 3 was named Self-Critical, Other Affirmed. This was the largest group with 278 employees, or 30%. Their self-mean was 3.68, but their other mean was 4.23, giving a positive gap of 0.55. This means colleagues recognize stronger value enactment than the employees recognized in themselves. A key insight is that the enterprise level weighted average gap was almost zero, approximately plus 0.02. But the clustering revealed 2 large and directionally opposite discrepancy groups hidden behind that aggregate. Okay, so what is the HR interpretation and discussion? The 4 clusters convert the culture review from a simple scorecard into a differentiated organizational development map. For cluster 1, the relevant intervention is not generate values communication. A better approach would be concrete behavioral feedback and expectation alignment. For cluster 1, the organization may use peer modeling or storytelling, but it should avoid labeling this group as superior. For cluster 2, the challenge is to preserve high standards while reducing excessive caution or perfectionism. For cluster 3, the issue is not weak external behavior. The issue is under recognition of one's own value enactment. Recognition and strengths-based feedback may be more suitable than remedial training. The study also has limitations. Self-ratings and other ratings can contain bias. K-means assumes Euclidean, convex partitions. The elbow method is judgment-based. The results are cross-sectional and company-specific. So what is the conclusion? To conclude, this project developed an interpretable K-means framework for organizational value profiling using self and other assessments. The main contribution is that an almost zero enterprise-level gap was shown to conceal two large and opposing self-other discrepancy groups. The project demonstrates how unsupervised learning can support people analytics by moving beyond average scores and revealing interpretable workforce patterns for differentiated organizational development. Thank you.